So we're going to continue with more examples. Can you find the zeros of this function and then write it in factored form? So it's a polynomial of degree 4. It has at most 4 zeros. By Descartes' rule of signs, it's already written in standard form. So I have positive, negative, negative, positive, positive. So there are 2 sign changes, which means there's either 2 or no positive real zeros. If I then compute f of minus x, we just have to change the sign on the odd powers. So this would be 2x to the 4th plus x cubed. Don't change this one, it's an even power. Do change this one, don't change this one. So we have positive, positive, negative, negative, positive. There are 2 changes, which means there's either 2 or 0 negative real zeros. Okay, so there's 2 or 0 positive and 2 or 0 negative. If we apply the rational root theorem, because every coefficient is an integer, any rational root has to be a factor of 2 over a factor of 2, and that works out to be plus or minus 1, plus or minus 2, or plus or minus a half. Notice this is 6 different numbers. They can't all be zeros. If we just test 1 first, always test x equals 1 or x equals minus 1 first, because they're going to be the easiest ones, and you might get lucky. Lo and behold, x equals 1 is a root. That means x minus 1 is a factor, which means the synthetic division step actually gives us what the quotient is. So we take the 2, the 1, the minus 4, the minus 2, and use them as our coefficients. The 2, the 1, the minus 4, and the minus 2. So here's how it factors. Notice that now I have a degree 3 polynomial. So I do the exact same thing, trying to factor the degree 3 polynomial. It has the same list of potential rational zeros. So let's try 1 again. Remember, roots can show up more than once. So just because you already found 1 to be a root doesn't mean it can't be a root again. But not this time. So 1 is not a repeated 0. Okay, so let's try 2. Nope. Maybe negative a half. Aha! Negative a half is a 0. So that means x plus 1/2 is a factor. And then the bottom row gives me the coefficients to continue the factoring. 2, 0, minus 4. So we were cubic, so now we're quadratic. 2x squared, 0 x's, and a minus 4, with the factors that we already found sitting here. So now I just try again with what's left behind, 2x squared minus 4. This can be factored pretty directly. I can factor a 2 out, and now x squared minus 2 is the difference of 2 squares. So it factors as x plus root 2 and x minus root 2. I disagree that this is the final answer. So we found roots, which means I should be expressing this as x minus a root and x plus a root. Okay, so the roots, we found root 2 and negative root 2, but they weren't given by the rational root theorem. Remember, the rational root theorem said that the quantity of, sorry, not the quantity, the rational roots would be plus or minus 1, plus or minus 2, plus or minus a half, and that's not what these numbers are. But remember, Descartes' rule of signs said either there are 2 positive or 0 positive roots, and either 2 positive or, either 2 negative or 0 negative roots. We found a single positive root, which means Descartes' rule of signs says there has to be another one. It's not going to be in the list of possible rational roots. You could just test them all. So 1 was a root, but none of the other positive ones are, which means the other root must not be in this list, which means the other root must not be a rational number. It must not be an integer over an integer. And root 2 is a 0 of this polynomial. It is not an integer over an integer. You can't possibly find 2 whole numbers so that the square root of 2 is the ratio of those numbers. Okay, that doesn't mean it's not a root. It just means it's not a rational root, and it wasn't given in the list of possible rational roots. I'm just re-emphasizing that the rational roots theorem tells you what the possible rational roots are. It doesn't mean there might not be roots that fail to be rational. Okay, so Descartes' rule of signs said if I had 1 positive root, I have to have another one. We tested all the rational numbers, and only one of them was a positive root. That means there's another positive root that's not a rational number. All right, do it again. 2x to the fourth minus x cubed minus 5x squared plus 2x plus 2 equals 0. Pause here, try to work it all out. All right, hopefully we did what we could. So we need to find zeros of this polynomial. So we already did this. This is the exact same problem as before. Here are all of the roots, which means the solutions are exactly -1/2, +1, and plus or minus √2. Okay, so keep practicing these. Come back. We have another video to cover about finding roots of functions.